In this video, we're going to take a look at the slightly more common case where instead of filling a Venn diagram in with numbers representing frequencies, we're going to be filling it in with probabilities. This is a great technique for solving a really broad range of probability questions. It's often the starting point for more complicated ones. Let's have a look at this. A survey of the reading habits of some students revealed that, on a regular basis, 25% read quality newspapers, 45% read tabloid newspapers, and 40% do not read newspapers at all. Find the proportion of students who read both quality and tabloid newspapers. All right, so let's try to represent this in a Venn diagram. Just visualizing it is a great way to solve these problems. Okay, so we're going to have two categories here because there are only two things being measured. One of them is whether they read quality newspapers or not, so I'll call that Q. And the next one is whether they read tabloid newspapers or not, so I'll call that T. So we've got four options, either quality but not tabloid, both, tabloid but not the quality ones, and neither. Find the proportion who read both. So ultimately we're looking for what this probability is in the middle. All right, so let's see what we can represent so far. So 25%, we are told, read quality newspapers. So this entire bubble here should add up to 0.25, but not just this bit. The most common error here is just to put a 0.25 here, but it's got to be both of these regions. And 45% read tabloid newspapers. So that means that all of this should add up to 0.45. And 40% do not read newspapers at all. Okay, we can fill that in because the ones who don't read newspapers at all are on the outside. So it's 0.4 here. All right. Now, how can we solve the rest of it? Well, here's the way I like to do it. If we know that the quality newspapers, that's this bubble here, adds up to 0.25, okay, this entire bubble here adds up to 0.25, then the only region unaccounted for, if we know that all of this adds up to 0.25 and this is 0.4, is this region here. So I know that all of quality plus 0.4 plus this little region here, and let's call this region X, should equal 1 because the whole lot adds up to 1. But I know that the entire Q bubble is 0.25. So what I have is 0.25 plus 0.4 plus X, which I'm interested in, equals 1. Okay, subtract this stuff, the 0.25 and 0.4 from both sides, and I get 0.35. So now I know that this region here is 0.35. Okay, and as a recap, that's because 0.4 plus 0.35 is 0.75, and then plus all of the quality newspaper region is another 0.25. That gets us up to 1. Now that I know this, the rest is quite easy to fill in because I know that 45% read tabloid newspapers. I've already got 0.35 here, so there's just 0.1 left. And finally, I know that 0.25 read quality newspapers. I've already got 0.1 here, so that must be 0.15. Now I have the complete picture. I can answer this question, find the proportion of students who read both quality and tabloid. Well, that's just the intersection in the middle, so our answer is 0.1. Okay, I hope that was useful to see how we can do a little bit of problem solving to populate a Venn diagram with probabilities.